Hi all, welcome back. And in this video, we are going to learn about segmentation, which is also a non-contagious memory allocation technique in operating system. And first, we will see how the segmentation happens. Why do we go for segmentation? And then we will look into detail about segmented paging and all. So let's say we have this LAS of ours, and in this LAS, let's talk about that there are programs and there are various modules. So what we do, we inside the LAS, inside the virtual memory, we divide our entire program into small segments, and let's say each segment carrying some module, some code like that. So let's say there are segments like S1, S2, S3, S4, and so on, and each segment is carrying some type of module or function related to the codes. For example, main function is there is one function foo, there is some modules like GCD, PDD, and so on, and there could be various type of modules and segment. So the basic idea is we are dividing the entire program present in the LAs into various segments, right? Now what happens that when the program execution starts, we are bringing some of these segments based upon what kind of loading or linking we are using. For example, let's say we are bringing some of these segments into this PAS, that is our main memory physical address space, and here we have the addresses, normal addressing mode on, like we have this 0 and let's say it's 1500, this is address, then this is 2500, then this is 3600, 3900. Okay, why I'm referring this like this, because see, let's say we brought some segment at 1500 location. Let's say S4 we bought at 1500 location. So whatever be the length up till that, the S4 will be accumulated here. So from 1500 to 2500, we have bought this S4 here, right? So the physical address of S4 will be, the base address will be 1500 up till 2500, right? Then we have at 3600 memory location, we have, let's say, S0, and let's say it is 300 byte. So it starts at 3600 and ends at 3900. Then we have bought S1, and S1, let's say the length of S1 is 400, so at 4300 it ends. And similarly we have some other segments, and then we have S3. So S3, we have loaded at let's say 5800 address, and let's say it ends at 6000. So in this way we have loaded several segments from this LAS into PAS. Now the basic idea is the CPU is going to generate, the processor is going to generate a address called the logical address. Now here the logical address will contain two parts. One is the segment number and other is the segment offset. Okay, now for we have this segment, but these segments are stored at different memory locations, so we don't know at what memory address this particular segment is stored. Therefore again we need some kind of translation strategy to map where these segments are present. So what we do, for each segment inside the LAS, we make them as the entries, we make them the indexes of this segment table. So here is our segment number. So for each segment, let's say we have altogether five segment or four segments, so we will make altogether four rows or five rows, and we'll mark them as S0, S1, S2, S3, S4, like this. And here we will be adding the base address, that is the base memory address of this segment. And in this size, and in this side we will be adding the size of each segment. So whatever base address at which we are storing these segment into the main memory, we are adding it here. So whenever the CPU generates this logical address containing the segment number and the segment size, so from here we are going to calculate where this segment is present inside the physical memory, and from here we are going to get the base address. For example, for S0 we have the base address 3600, and let's say the size of this is 300. Okay, similarly for S1 we have the base address as 3900 and the size is let's say 400. Similarly for S2 we have okay, let's say, but let's store S2 at some address like 7000. So here we are storing S2 and let's say it's 8000. So we have S2 at 7000 base address and the size of S2 is 1000. And in same way we have for all segment we have some entries, right? So whenever CPU generates the logical address from the segment part, segment number, we will be referring to which segment is it is trying to refer to, and from here we are going to get the base address. So this is the base address and this is the size, or you can say the limit or length, whatever. Now from here we are taking this base address and then we are trying to sorry, from here we are taking the base address and accordingly we are taking the size. Okay, now here what happens that we are taking the size and let's say the length is here L. So this is the length. So we are taking the length and then we are comparing it with this part, that is the D. So D is nothing but the segment size. So if D is equal to L, or if L is less than D, then it is right length, that is we go to yes. But if the length is greater than D, or then we have this as a trap, so this goes as a trap. So whatever length of size we have here and whatever length we are requesting, so D has to be less than L. Either D has to be less than or equal to L, right? So here if the D, I mean the segment size, whatever segment offset we are referring to is less than the limit, then we go ahead and what we do here, we add this base address. From here we are taking the base address and here we are adding the base address and the limit, and then we are referring to the particular part. We are fetching the instruction from the particular part inside the PAS. So here we are adding the base address and we are adding the L, that is the limit, sorry, the D. So we are adding the B, this base address and the D, and then we are trying to look into for the particular segment inside this main memory. So this is the entire process, and in this way we try to access the particular segment from the main memory, right? So let's see some of the question, but before that I would like to illustrate, make it a note for few points. So the paging, this concept is similar to how the user views the memory allocation. So paging does not follow, actually paging does not follow users view of memory allocations, users view of memory allocation. So to achieve users view of memory allocation, to achieve users view of memory allocation, we implement segmentation. Segmentation is implemented. Okay, so to achieve users view of memory allocation, segmentation is implemented. So in segmentation, what happens? LAS, or the logical memory address space, is divided into various segments, divided into various segments, and segments are of variable size. So we are not fixing the size of the segment can be of variable size, and some of these segments are brought into the PAS, physical address space, from LAS. Some of these segments are brought into the PAS from LAS, right? Okay. Now, if the CPU generates a logical address consisting of S and D bit, so S denote number of bits required to represent a particular segment in the LAS. Number of bits required to represent the segment in LAS, right? And it is also known as segment number, right? And what is this D? So this D is number of bit required to represent the segment size, or it is also known as a word segment offset or word number of segment. So number of bits required to represent segment size. Segment size. So here it is also known as segment offset, segment offset, or we can say it as word number of segment. So these are some synonym for that, word number of segment, right? Now, number of entries in the segment table is also known as is also same as the number of segments in the LAS. Like number of pages in the page table is same as the number of pages in the LAS. So number of entries in the segment table is same as number of segments in the LAS. Same as number of segments in LAS. Whatever be the number of segments in the LAS, that segment has a corresponding entry in the segment table. Okay. Now, we were talking about this D and L comparison when we talked about this diagram. So we are comparing this D segment offset or word number of segment, uh, or we can say the number of bits required to represent the segment size. So we are comparing this D with L. Now L is the maximum size of this segment. So what is this comparison? So basically we are comparing D has to be lesser than L, because L is what maximum segment size, or you can say the limit of segment, maximum size of segment, and this D is nothing but segment offset or number of bits required to represent a particular segment, right? So D is nothing but something like the word number of segment. Okay, word number of segment. So D has always to be less than L. So if D is 210 and the limit is 200, then definitely it is a trap. Why? Because the limit is 200 and we are trying to access something which is greater than 200. So it is a trap to OS, right? Similarly, if we have the D is equal to 190 and we have the L as 200, here it is a correct match because D has to be less than L, so this condition is satisfied. So whatever we base address we will be getting from the segment table, so whatever base address we need to add to the D, and this will give us the address of the particular word that the CPU wants to access, right? So this is the condition. So base address plus D is equal to PAS, right? So if base address is 5800 and D is 190, so our required word will be present at 5990. Okay. One more thing to note here is the variable size segments. The variable size, because each segment is of variable size. So the variable size segments are brought from LAS to PAS, are brought from LAS to PAS. So it is similarly, it is behaving similarly, it is behaving similar to variable partition scheme. Variable partition scheme, right? We remember variable partition scheme from starting lecture. So hence segmentation can also suffer from what is known as external fragmentation, because in variable partition scheme we have a problem called external fragmentation. So segmentation also suffers from external fragmentation, right? So this is one issue with segmentation. So I think it's a very small topic. We'll see more how to eliminate this external fragmentation in the segmentation part, but keep this diagram into your mind, and we'll see about segmented paging in the upcoming lecture. And if you do have any comment or question, please do comment in the comment section. So thank you very much for watching.